Okay, so thank you all for coming. My name is Travis Ellis, and I am with Deliveron Consulting Services. Been with them for about 9 years now, and working in Service Fabric for the past year, maybe a little longer. So how many people here have heard of Service Fabric or are using Service Fabric? Oh, almost everybody. Okay. Well, what is Service Fabric? Service Fabric is a distributed systems platform that makes it easy to create microservices, reliable, scalable microservices. What are microservices? Microservices are pretty much a modern interpretation of service-oriented architecture. Kind of came about after DevOps was introduced around 2014 area. So a few of the principles of microservices: high cohesion. Service should do one thing and do it well. They should be autonomous. They should be easily deployable, versionable, etc. They should focus on a business domain. They should be resilient. You should expect failures because, as you know, anytime you have code in production, it is going to fail. Servers fail, hardware failures in general happen. So plan for those failures. Make sure your services are resilient. They should also be observable. Make sure that you have centralized logging and monitoring, and also plan for automation with tools for deployment, etc. Service Fabric is built primarily, I guess you can build it through Azure or on premises. I'm going to primarily focus on the Azure side of things. That's what I've done the most, but it also runs on either Windows Server or Linux. So when I'm talking about microservices from a Service Fabric standpoint, I'm going to focus on what we call reliable services. Reliable services, there are two different types of services. There's stateless services and stateful services. Stateless services, as the name implies, you do not store any state. At least from a Service Fabric perspective, not within Service Fabric. You can always have an external data store like a SQL Server database, etc. Stateful services, on the other hand, you actually store state within Service Fabric. And then actor services are kind of built on top of stateful services. They are an implementation of what's called the virtual actor pattern. And basically they work on a turn-based threading model, so like single-threaded, highly scalable services. Reliable services also have full access to the Service Fabric SDKs. For example, the health reports, load metrics, etc., and the naming service. So Service Fabric also allows you to host pretty much any executable. You can, it's what's called a guest executable. If it was written in Java, written in something else, you could actually package that up and have Service Fabric manage it. And then recently, within the past 6 months, they also added container support, which is pretty much grown in popularity over the past couple of years. So Service Fabric is, go ahead.
Could you explain a little more about stateless versus stateful? Is that like session state kind of thing, or is it something else?
Basically, it's any sort of data kind of serialization. So stateful services within Service Fabric specifically, there's a couple different storage mechanisms. The most common would be a reliable dictionary. It's essentially like, consider it like a concurrent dictionary within .NET with transactions, essentially. So the way that works, and I'll kind of cover that, but essentially with Service Fabric, Service Fabric has a concept of a cluster. It's essentially multiple nodes, connected, in a network. So when I store state, it could be anything like, instead of using a database to store customer data, for example, I can store it in a dictionary, essentially, and when I store it in a single node, it actually gets replicated to at least 2 other nodes. And what that means is if the node that the primary replica is on goes down, it actually still has at least two others that it can fail over to. So with stateful services, you get high availability out of the box, essentially. Stateless just means that there's no state stored within Service Fabric. Again, you could still use like SQL Server for external storage, or any sort of relational database, or a document database, et cetera. So it's specifically referring to storing state within Service Fabric. So the Service Fabric application model for reliable services. A service can have multiple code, config, or data packages, and you group multiple related services into a single application. Each code, configuration, and data package is independently versionable. So if I make a change to just data or just config, I don't need to restart any of my code packages. I don't have to update the versions on those, et cetera. So when you deploy that, and I'll kind of go over that in a demo, but sorry. So and when I mentioned applications and services, I'm actually, when you're talking about describing applications and services, you're actually talking about application types and service types. So Service Fabric, you describe a application and service in a manifest. That basically tells it what code, configuration, and data packages it has. And then you package that up, send it to your cluster, essentially. And you can instantiate multiple instances of those applications and services. So it's helpful to think of the service and application types as classes, and the named services and applications as the instances of your class, similar to something like C#.
When you say code, that's compiler, so that's binaries?
Exactly, yeah. So a code package would be your executables, your binaries, assemblies, et cetera. Configuration packages is going to be read-only configuration data, and then data packages are similar, but they're really just static read-only data, not for configuration. When you're talking about services, one of the ways that you can scale out services is through partitions. So a service might have one or more partitions, and each partition will have one or more replicas. When you're talking about stateful services, you're talking about replicas, and when you're talking about stateless services, you're talking about instances. That goes back to what I was mentioning earlier. When you're storing state, the replicas are basically where it persists the multiple copies, essentially. With stateless services, there's no replicas because it's not stateful. It's just, you call them instances in that case. But they're pretty much interchangeable terms in the first place. So one of the ways to partition state would be using what's called range partitioning. So think of if I am storing census data as an example. One of the ways you might store this data is by county. So you have Douglas County, Lancaster County, Madison County. So if you're storing census data, you might store all of the data for Douglas County, in one partition, all of the data for Lancaster County in another partition. So that's probably not a very good partitioning scheme, though, because obviously Douglas County has a lot more people than Madison County. So you could partition in other ways. For example, this is kind of showing a range partitioning scheme where your keys are 0 through 99. That's just kind of any sort of numeric range. In order to determine which partition to go to, you kind of calculate a hash code to figure out which partition to go to. So in this example, if I calculate the key 0 through 24, I'd be going to partition 1. If I do 75 through 99, it's partition 4. And then the partitions have always have a single primary replica and then at least 2 secondary replicas. And that's just, again, for replicating the state. as an example, if I have a 5-node cluster and I have 10 partitions in that cluster for one of my services, you would expect to see in Service Fabric that each node would have 2 primary replicas. 10 divided by 5 is 2. And then since each partition also has 2 secondary replicas, you would have 4 secondary replicas on each node. If I were to then scale out my cluster to add an additional 5 nodes, now I have, again, 10 partitions and 10 nodes. Service Fabric would kind of distribute those partitions so that you have 1 primary replica per node and then 2 secondary replicas per node.
How do nodes correspond with actual Azure virtual machines that you're paying for?
I'll kind of show that, but essentially a node you can just consider it as either a physical or a virtual machine in the cluster. So I'm not big on slides if you've ever seen me talk before, so I kind of like to just rush through them and just demo things. So let's go ahead and jump right in. And again, if you have any questions at any time, feel free to interrupt me. The first thing I was going to show, I have an agenda here, make sure I follow that. I want to show an example Service Fabric application. And I just realized that I did not connect to the Wi-Fi, so I'm going to have to do that.
I don't think there's a password.
Okay.
You can just log right in.
Is it AMX 201?
No, the guess. There's an F
Oh.
in America guess near the bottom. Scroll down. Right there.
That one. Okay. Thank you. Okay. It's not a demo if something doesn't go wrong. So. Okay, so I'm going to go ahead and create a Service Fabric application here.
If you go to web browser and accept the
Okay. I read all that. I'm a very fast reader. So. Okay. So when I create a Service Fabric application, I'm going to be prompted to create a service within there. There's multiple templates that you can choose from. Again, I talked about stateless services and stateful services. These are pretty much just bare bones services that kind of have like a loop that kind of is considered like a background processing service. Then there's the reliable actors, guest executable. So like I mentioned before, you can actually package up any executable code and have Service Fabric deploy it. I can also do containers. And then there's 2 ASP.NET Core templates as well, one for stateless services and one for stateful services. So I'm just going to create a stateless service. Down here I can give it a name, which in this instance is not really important. I just kind of want to show how you describe the services with the manifest. Okay, so this is my Service Fabric solution. You're always going to have a container application. This is the consider it the project that just manages all of the services within the application. And then this is my single stateless service that I put in the project. So within there is a package root folder. Can everybody see that okay, or should I zoom in? Zoom in? Okay.
Eyes are good, but not that.
How's that?
Yes.
Okay. So package root folder, that will contain your service manifest file. Okay. So, okay, this is the manifest for the service. So obviously it has a name and a version. And then I mentioned before that there's multiple code, config, and data packages. There's also multiple service types that you can kind of put in a service package. I'm not really going to go into that. It's kind of a weird use case that you probably wouldn't do very often. So For this example, though, this is the service type that I mentioned before. So this is kind of the description of the service, or consider it the class that you would instantiate. So within here, I have a single code package. By default, when you create a service, it is just given a name of code, and then version 100. This one has a single entry point for my service, stateless1.exe. The name of the service was stateless1. It essentially matches the assembly name when you build the program. When you create a packet or a service, you also get a config package. Again, it's just named config. You can have multiple, but the convention is just to call it config by default. This doesn't have a data package, but if I were to just go ahead and add that name by default, I could use data. Okay, so this actually just corresponds to a folder within my solution, and actually specifically within package root. So config, there's a folder that is the config package. So if I were to look in there, I have settings XML. This is where I would stick any sort of configuration data for that configuration package. It's just an XML file. It doesn't have to be an XML file. You could store configuration data in JSON, but when you're working with the APIs kind of assume you're working in this specific settings file. So if you wanted to use JSON, you just kind of have to write your own code to interact with it. So, okay, so moving on, I'm going to just zoom in, make it easier than using the zoom. Okay. So in addition to describing the code configuration and data packages, you also have the ability to add specific resources within here. Most common is going to be the endpoint. So Service Fabric, any communication that you do in Service Fabric, it's protocol agnostic. You can use HTTP, TCP, WCF, anything you really want. Service Fabric doesn't care. You just kind of have to tell it what ports essentially to open, or actually not to open, but to put in the naming service. One of the services that Service Fabric has out of the box essentially is like a little DNS system. So if I need to communicate with another service, again, you're going to have multiple nodes in your cluster. So if Service A needs to talk to Service B, you need to know essentially where to go to find that. And that's where the naming service comes in. So essentially you just tell it a specific port if you want to. If you leave it blank, it's going to use a random port. So then you would have to use the naming service in order to know exactly where to go. So that is the manifest for a service. Similar to the service manifest, there is the application manifest, and that is under the application package root folder in your Service Fabric app. So again, so the application has a application type name and then a version, and then all of the fields in here can be parameterized. So I'll kind of explain that a little later. But then I also have to tell my application all about the services within the application. So right here, I am importing the stateless1 package that I kind of showed the manifest for before. If I want to override any configuration data, I can do that in a config overrides field. And then also have default services. So when I create an instance of an application or a named application, these are all the services that are going to start automatically. You don't have to have every single service in your application start when you create an application. You can actually control that through the default services. So And one of the things with Service Fabric, if I need to spin up instances of a service, I can do that at runtime by using the SDK. So these are just the ones that will start automatically. So next on the agenda. So I know I'm kind of going through this pretty quickly, but I just kind of wanted you to get familiar with the application model. I don't actually need any of this. Okay. Uh-oh. Okay. All right, so the next thing I kind of wanted to show, of course, is when you create a Service Fabric cluster, what do you get out of the box? So I already created a cluster in Azure. Again, you can run Service Fabric on premises. It's just a less common scenario. You need multiple machines, obviously, or virtual machines, etc. You can run a cluster locally. It just kind of simulates having multiple nodes, and I'll show that. So I have a resource group in Azure that contains my cluster. And let's see if I can zoom in. Okay, so when I create a cluster, I name my cluster .NET User Group. This is just kind of a container resource within Azure that essentially is what I interact with the most. There's really not a whole lot to it, but the meat of the cluster essentially is going to be a virtual machine scale set. Essentially, a virtual machine scale set is, instead of having to manage, hundreds of nodes and seeing every single one within Azure, the virtual machine scale set describes a specific virtual machine profile, and then within there, I can see all of the individual machines that are in the scale set. Also, just based on its name, it implies it is easy to scale. If I need to increase the number of nodes, I can, redeploy and increase the number pretty easily. So you can see I have a cluster that has 5 machines. When you create a cluster, the minimum number of nodes for a production environment is 5. Essentially, the services that run within the cluster, they all have a replica set size of 5. And that's kind of going back to the stateful services thing I was mentioning before. Any state that is stored, it replicates to 4 nodes instead of just 2 other nodes. So what that allows me to happen is if I were to lose 2 nodes, I would still have everything up and running because it can always essentially fail over to the additional nodes. As soon as you lose essentially what they call quorum, the majority of your nodes, then it kind of goes into a warning or error state. It's not going to allow any more writes to your stateful services because it can't guarantee that it's has sufficient nodes to replicate. So as long as those nodes come back though, then it'll kind of go back into a normal state. In addition to the virtual machine scale set, I also have a load balancer and a public IP for that load balancer, and then a number of storage accounts. One of the storage accounts is for the virtual machines, the hard drives, the virtual disks, and then another one is to store Service Fabric diagnostic data. And the last one, Service Fabric is kind of built on top of using event source, ETW, event tracing for Windows, and all of the events that kind of get sent or captured within Service Fabric get sent to the storage account. Okay, so let's go ahead and right here. Okay, so as I mentioned, my cluster is named .NET User Group, and when I create a cluster within Azure, I get this handy little tool called the Service Fabric Explorer. This is showing me my cluster that is deployed to Azure. As you can see, I have 5 nodes within the cluster, and then I have 1 currently deployed application, 5 services, 60 replicas. This is kind of the overall picture of the cluster and the health. As you can see, everything's green, everything is healthy. But if I were to look at the application, I can drill down in to see all of the services that are within here. So I mentioned before that there is a concept of the application type and then the application instances. So, sorry, I probably need to zoom in for you guys to see in the back. Okay, so this is the application type. It's called getting started application type. And then within there, this is the deployed application. Again, I could create multiple instances of the application. And again, underneath there, these are all the services that are running. So this application has 5 services that comprise the application. And then I can drill down into that and see the partitions for those. So for example, this actor service has, I think it's 12 partitions. 3, 4, 5, 6, 7, 9. Sorry, 9 partitions. So again, when you look at that, since I have 5 nodes, essentially some of the partitions are going to be on the first node, some on the second node, et cetera. And you can actually expand that out even further to see which nodes they are on. So the first partition in the actor service is on the node 2, essentially. You could also look at it from a node perspective and see node 0 has Fabric getting started application deployed to it. Underneath there, you can see the web service package is deployed on there. See the code packages, the instances are running, et cetera. Okay, so essentially the Cluster Explorer is what you're going to interact with a lot just to see how things are running. You can send a lot of this data to other places like I mentioned all the events go to the storage accounts. You could also consume that from within something like OMS. So, but just to see a kind of overall picture of the cluster and the health, the Cluster Explorer is what you'll use. Yeah.
Can you scale the number of nodes up and down dynamically, like in response to load?
Yes, it's not a feature of Service Fabric. It's a feature of the virtual machine scale set, and I could probably show that real quick. If I go into the virtual machine scale set, you can see this scaling tab right here. So right now I have 5 nodes. I can enable auto scaling, essentially kind of say how you want to scale. If you hit like a certain CPU threshold, like let's say 60% CPU is being utilized, then I can increase the number of nodes. So what's going to happen when you add a node to your cluster, let's say I have 20 services deployed to the cluster. And just to make it simple, just say 1 partition per. So that's going to be essentially 4 services per node. When I increase the number of instances, though, Service Fabric is going to start distributing them across the new instances of the node. And that's, again, why you kind of have to plan for failures, is because Service Fabric is just going to move things while things are running. It's essentially, if you only have a single instance of a service, there's going to be a brief time where it might be unavailable. It should recover very fast, though. So and that's where the naming service comes in. If I ask Service Fabric what is the IP and port for service A, it's going to cache that data. It might tell me it's on node 1, port 8000. But if Service Fabric redistributes services based on more nodes coming in, then it might when it moved. If I try and hit that URL or the IP and port, it is probably going to error out, and then Service Fabric is essentially going to re-resolve that at that point. So most of the code, the communication code, got dark. Most of the communication code within Service Fabric is actually going to have that retry capability built in. So, okay, so. All right, I want to show a quick example app. Okay, so I created a service called the .NET User Group Service. There's nothing special about it. It has a stateless service and a stateful service within there. So I'm going to run this on my local cluster.
So the service fabric and the application are going to be two different projects solutions, right?
Say that again.
The service fabric that you created initially that had all the config settings and whatnot.
So that was just an example solution I created to show. This is just another application. So the one I just created just to show you the manifest files. These are pre-built services that I created before this. Sometimes it can take a while to get things up and running. But in addition to my, this is the cluster for that I have hosted in Azure. I also have a cluster running locally. So you can see that it is currently deploying my application. So there we go. All right, so now it has the type, and then it just created an instance of that. If I look, you can kind of see that it's not quite up and running yet. These question marks essentially mean, that's kind of in the process of building it. So now I have a stateful service, a stateless service, and a web service. So these are the three services that I had within there. These services don't do a whole lot, but kind of wanted to show when I start a service. Okay. So I mentioned before that Service Fabric will use ETW to send out a bunch of events. That's essentially what these are right here. So I have a stateless service that essentially, I think might be every 10 seconds, it's just putting out a message through ETW. So counter 12, counter 13 essentially. And then I have a stateful service with 2 partitions, I think, that is also kind of doing the same thing. It's going to increase a counter every few seconds. So actually, I'm going to go ahead and stop this. And instead of debugging it, I'm actually just going to publish it to my cluster. Oops. Cancel. Okay. All right, so I will show the code for this real quick. I mentioned before that one of the templates for the stateless service is essentially just like kind of a background worker. The entry point for a Service Fabric service is going to be run async. Essentially, when you start the code package, it's going to go into run async. At that point, you can kind of set up a loop or whatever to kind of keep the service alive. This one just kind of infinitely has a while true loop. And looks like it's configurable, but every 30 seconds or so, it's going to put out this message that says stateless service counter, and then whatever the number of iterations is. So make sure it's starting this. Okay. Similar to the stateless service, the stateful service does almost the exact same thing. The difference is that the stateful service, when it increases the counter, it also stores it in a dictionary, and that's using the stateful side of Service Fabric. So when I save that, it's going to get persisted to additional replicas. So basically create a transaction within the state manager, try and get the existing value if it exists or not, and then I output the value and then update the value within the dictionary and then commit the transaction.
Where does the dictionary come from?
The dictionary essentially just creates, from the state manager, creates a new reliable dictionary. Again, reliable dictionary is kind of a, so within .NET there's the dictionary and then concurrent dictionary. Concurrent dictionary is essentially thread safe. Reliable dictionary is kind of on top of concurrent dictionary with persistence to multiple replicas. So hopefully that is started now. Okay. Yep, so it is up and running. So I can still view the diagnostics data when. So I'm no longer debugging, but I should still see the events come through. Get over here. Okay, so stateless service counter is 18, 19. It's essentially going to keep increasing until I stop the service. I mentioned before, though, that the services can have configuration packages. So this one actually has the number of seconds to wait between putting out that message in the configuration package. Right now, essentially, an event is going to fire every 5 seconds that kind of outputs that value. So one of the cool things I can do, if I look at this code again, that is the stateful. Nope, that was stateless right here. Okay, so when this service starts, the very first thing it does is says, okay, I need to update the processing interval. And what it does is it pulls that from the configuration package. So uses that processing section and interval in seconds and converts it to an integer. And then it just sets this, oops, that's if it doesn't exist in the settings. Essentially sets that a time span with that value. It uses that to do a delay. So every 5 seconds, I'm going to see this event happen. So if we look at this, let me do filter the message. Okay, so we should see this happen roughly every 5 seconds. What I'm going to do now is go ahead and open my settings, and let's change this to 1 second, and edit my versions. So I am changing my stateless service, the config version. I'm not touching any code. Essentially, I'm only changing this XML file. And so because of that, I don't need to actually update my code version. If I update my code version, it's going to restart the code. Essentially, it's going to be a new binary. It would have to essentially put out a new version of that code and then stop the existing services and start the new ones. If I do that, since I'm not actually persisting that value, I'm going to lose whatever my current counter is. But since I'm just updating the configuration package, if we look at the code again, I have this event here. When the configuration package is modified, it's going to fire off this event handler, which is just going to call that update processing interval, and then essentially set the time span. So if I go ahead and publish this and do an upgrade, we should be able to see first, if I look at my cluster, I should start see this come up to do an upgrade. So I'm going to clear these events. Okay. All right, registering, starting the upgrade. So, okay, so you see it just kind of came up and is now upgrading from version 1.0.0 to 1.0.1. If we look at the stateless service, it is on node 0. So this should be the first one that actually goes through. So if we go back and look at the diagnostic events, now you can see the events are firing much faster, essentially one every second. So 86, 87, 88. So the upgrade the upgrades in Service Fabric are, for the most part, rolling upgrades. I didn't show this before, but if I look at the view of my cluster, I can see a cluster map. Since I only have 5 nodes, it's not as interesting, but essentially it organizes the nodes into separate upgrade domains. And when it does upgrades, essentially goes upgrade domain by upgrade domain. So all the nodes in upgrade domain 0, it's going to upgrade the code and then check to make sure the cluster is healthy. And if it's healthy, it's going to continue. If at any point it starts seeing failures within your services that you upgrade, it'll actually can do a rollback and kind of go back to the previous version. What's nice about this is there's no downtime between any of your upgrades. So it's just going to continue on and do the next upgrade domain. One of the things that you have to kind of be careful of, though, when you do this is you're going to have code, especially if you have like a service that exists on multiple nodes, multiple instances. You're going to have some nodes have version 1 and some have version 2. So you have to make sure that any code you write is backwards compatible. So it's not something you can just kind of throw out there and expect to work. If you're expecting something to have a very specific format, you have to make sure that you maintain both future and backwards compatibility. So let's see, upgrade is for some reason kind of stopped, but that's weird. Oh, there we go. It's much slower than I would have expected. Probably change the upgrade type. So what I mentioned before is there's multiple ways to do the upgrades. There's an unmonitored upgrade, which means that when it does the upgrade, it doesn't really care about the stability of the application. It's just going to go through it. I changed it earlier to be a monitored upgrade, which means that it's going to upgrade one upgrade domain, check for healthiness. So essentially, it's going to wait like a specified amount of time. It might be like 30 seconds, 60 seconds. And if it determines it's healthy, it's going to move on to the next one. So when you do those upgrades, they're a little slower because essentially it has to wait to make sure everything's stable. Because if you just check for healthiness like right away before you let for example, if you're starting up a web API, if there's any sort of costly initialization, you don't want to check for health before you just move on because it's not going to be healthy for potentially 30 seconds or so. So, okay.
How does it check for health? What does it consider to be healthy?
So Service Fabric actually has a pretty robust health system. You can actually use the SDK to do your own health reports. But if the service does not come up, for example, it just crashes during startup, that would essentially cause a health report to say that, hey, this thing is not running. You can also do your own health reports. Let's say you are dependent on an external service, maybe a database or another web API. If you try and contact that web API and it doesn't respond, you could put your own health report saying, hey, there's either a warning or an error, and it would use that as kind of its health check. So essentially, there's going to be Service Fabric built-in ones, but then you can do your own as well. So, okay, so this upgrade is almost done. So what I'm going to do now, oh, I have to wait for it, unfortunately. Okay. It's not a demo if it doesn't take a long time. All right. All right, what I'm going to do while we wait for this is move on to a different application that I have an example for. So this application kind of shows a lot more within Service Fabric. Okay, so this is deployed out to my cluster, .NET User Group, Central US Cloud App.azure.com. This is one of the built-in Service Fabric samples that kind of just show you a little bit more about how to use different things. It has a stateless service, which pretty much does the exact same thing the service I just showed you. It increments a counter every few seconds. But it exposes a web service that is communicating with that service, essentially using, I think, is remoting. And so you can get that count without having to view the service events. So if I hit this get count, you're going to see it kind of change every few seconds. So what you might find funny is sometimes it's going down, sometimes it's going up. That's because depending on which replica or instance it talks to, the number is going to be different. So I think this service is hosted on, let's see here. Getting started, the stateless service has one partition, but it's deployed to all 5 nodes. So it's going to essentially talk to a random node and get the count for that random node. So it's not just going to be constantly increasing. So now if I were to look at a stateful service, the stateful service example just kind of shows you all of the different values that are in here. I can add a couple values to it. It's going to essentially store that value in one of the partitions. Again, based on the partitioning scheme, I think this one has, okay, finally succeeded. This one has 1, 2, 3, 4, 5, 6 partitions. So when I create that, or when I talk to the service, essentially I need to figure out which partition to go to and then communicate directly with that partition. I mentioned before that one of the ways to do that would be to use a hash algorithm. So if I am, for example, storing things, I think this example looks at the first letter in the word that I give it, and then it calculates a number between 0 and 26, and then, or sorry, 0 and 25, and then it will essentially, based on the number of partitions I have, determine which partition to go to. I could also, if I wanted to, just use like a name partition. Again, like the example I gave earlier would be like if I'm storing census data, the name of the partition could just be the name of the county, as an example. Okay, so now that this service has been upgraded, I'm going to go back, jump back to this since it was taking a while. I'm going to update the code package this time. Okay, so go back in, change this back to 10, and do an upgrade. This time I'm going to change it. I don't want it to take that long, so. Okay. All right, so what we should see this time is, since I did upgrade the code package, before I do that, yeah, okay, so current value is 600. So when it does this upgrade, it's actually going to reset that number because it had to restart the code package. Okay, registering application. Okay, upgrade has started. Okay, so we see the upgrade from 01 to 102 and going again by upgrade domain. So if I monitor this, pretty soon I should see it. Yep, it just reset the counter. So because I restarted the code package, essentially that's a new binary. I can't just move from one and keep all that state. So it's going to essentially reset that count, since I'm not persisting it in any sort of database or stateful service. And that is going much faster than the other one. Now, what I will do is I also have a stateful service that is kind of doing the same thing. It has 2 partitions, I believe, then it's upgrading. Actually, maybe it's 4 partitions. It's upgrading this counter similar to the stateless one. So I'm going to go ahead and edit that. So the stateful service, if I update the code package there and do an upgrade. Okay, so what we should see here is that the stateful service is not going to, it is going to stop the services and restart them, but since I'm persisting that state in a reliable dictionary, it's essentially going to keep my count where it is already. So, okay.
Question.
Yep.
So you've got the config file with those configuration settings.
Yep.
When you're developing, you would have those be your dev settings. What facilities are there to have different settings and make it seamless for
Good question.
QA and
So-
RD and prod?
Yep, so I kind of glanced over it before, but in your application manifest, when you import the service package, there's this config overrides. So at that point, I can actually specify which settings I do need to override. And then you see up here, I have these parameters. I can specify default values or so for example, if one of the things I needed to override was that processing interval, I could add a parameter here. And then I also have multiple publishing profiles and parameters files. Why do I keep getting? Okay. Oh, I think I keep on dragging accidentally. So I have multiple application parameters files, so I can store individual configuration for the environment here. For example, this one is the cloud profile. So the number of partitions I want for the cloud is 13. But if I look at the local 5 node, I'm only doing 4 partitions locally. So that'd be where you would put the individual configuration overrides. It'd be in a profile. When you do deploy an application, everything I'm kind of showing here through Visual Studio, you can actually do with PowerShell. So you can kind of provide those overrides however you want. So, okay, so upgrade looks to be done. So if I go back to the events, so what you see here. So run async has been invoked for a stateful service replica. That's going to happen when it started your service. You see that there's no reset in the counter value. So essentially, it restarted all the code, but since all the state was stored in a stateful dictionary, essentially it looks like there's no interruption at all. Okay, next.
Can you put any kind of object in that dictionary?
As long as it's serializable, I think like data contract serializable is the stipulation. But you could also, if you wanted to, you could store JSON. Again, it's a dictionary, so you have a key, and then if you use just a string as whatever the value is, you could store JSON. And then, again, the one thing you have to make sure you do is make sure that if you are changing the contract of that, you maintain backwards compatibility. Because again, you're going to have code that is still on version 1 while you're doing an upgrade. And if you're pulling something from one of those nodes that are still on, if you upgraded service A and it's pulling something from there, and if it's the old version and you're expecting new fields, it's going to break.
Will
So-
it break if it can't deserialize it? too?
I believe so. So, yeah, got to make sure that things are always, backwards and forwards compatible. Okay, so also I kind of showed the upgrade of the config packages. Just show data packages now. Data packages are very similar to config packages. The only difference is you can store the data however you want. Again, it's just a folder or it's just a file in a folder. So you can store it in JSON, XML, your own custom format. It's just read-only static data. So I have this Postman thing here. I have a web service on that service that essentially is just returning JSON from that service. So if I show that, okay. So the web service has a controller. I keep on dragging it for some reason. Okay, so the get essentially just calls get all values. If I look at the implementation of this, it is when this class is initialized, it is getting a data package object and then reading from a JSON file. So values.json and then deserializing that. Essentially just an array of strings. So if I look at the data package, essentially it's just value 1, value 2, value 3 right now. So when I call this, I see value 1, value 2, value 3. So if I go ahead and update this, and update my data package. Where are you there? It's also worth mentioning that these version numbers are pretty meaningless. Right now, they're just kind of semantic versions. So however you want to version them, you can do that. When I edit the versions through Visual Studio, if I update the lowest level, essentially it's going to automatically bump up the versions on the next level. So if I update a data package, it knows it needs to update the service package, and then that would make me update the application package. But you can use whatever you want for versions. I could have version foo and a version bar. It doesn't really care. Service Fabric doesn't, but if you do that, then Visual Studio doesn't really know how to kind of increase those versions. So I'm just going to name this one Apple for fun. So if I go ahead and publish this, again, I should see, once it does the upgrade.
While we're waiting, another
Sure.
question. Are you going to show what it looks like to have one service talk to another service?
Yes, I will do that. While that is upgrading, since that's kind of the boring part, I will show that. Again, I mentioned that you can use any communication stack you want. The easiest one to kind of get set up is remoting. Essentially, you have your service implement an interface, and then all the methods that you kind of want to use to communicate they have to be task returning async. So if you implement that interface in your service, then you can kind of use that to communicate. But otherwise, the most common one would just be using HTTP, so you can use HTTP client and then tell it, essentially you have to use the naming service at that point. So to figure out which IP and port to communicate with. So I will show that while I look. I also have a post method on the same controller. Essentially, it uses service proxy.create with that interface that I mentioned, and then I give it the URI of the service I want to communicate with. So in this example, Fabric.NET User Group Sample Stateful Service. That corresponds to the so this is the running application, and then sample stateful service right here. So that is the full named service. So if I want to communicate with that one, essentially then I need to use that name. Again, you could have multiple instances of the same service running, so you have to kind of tell it exactly which one you want. This service, again, it's the stateful service, has 4 different partitions when I run locally. So because I have multiple partitions, I need to tell it which partition to go to. So the second parameter of the service proxy create is a partition key. And in order to get the partition key, what I'm doing is I'm taking whatever value you use, and I mentioned before, I'm getting the first letter of that key, and then converting it to a value between 0 and 25. So essentially, A is going to be 0, B is going to be 1, C is going to be 3, or 2, I guess, since it's 0 based. So because of that, since I have 4 different partitions, essentially 0 through 6, I think, is going to correspond to the first partition. 7 through 14 or so are going to be the second partition. Service Fabric takes care of that. You just know you need to communicate with one of them based on your key. So how you determine what those partitions are, it doesn't matter. I kind of skipped over this, but when I set up this service in the manifest, when I set up the stateful service, I'm telling it what that partitioning scheme is right here. So I'm giving it the number of partitions, and then right here it's partition count is 4 in this example, and then the low key is 0, the high key is 25. In a normal service, you might have the default is going to be int64 min value and int64 max value. So that's billions of numbers. So essentially, you could partition and have billions of partitions, and running on thousands of nodes in your cluster. So you just essentially when you do partition, you just got to make sure that you're kind of equally distributing, because you don't want that scenario that I gave in the census where you have one partition or node that's hot and the rest are cold, because then you're not really balancing your cluster. Okay, so I think that upgrade is probably done now. So, all right, so now when I call this, I get .NET user group from the data. Essentially, again, since I didn't update the code package, you didn't have to restart anything, so you don't have that slow warm-up time when you do start a service and do the just-in-time compilation. So I will show. Okay, so I have the same controller here doing a post instead. That is the, oh geez, hard to see. If I go back to my controller. Okay, so the post, essentially what it's going to do is use this remoting interface. The remoting interface just has a single method called getDetails, which is just a task returning again that returns a string. The interface has to inherit from this iService, which is in the remoting namespace of Service Fabric. And then if I look at the implementation, that is in my stateful service itself. You see I implement that interface, and then I tell it how to what I want it to actually do. In this case, I'm just returning which partition it is and which node it's on. So if I were to call this, again, the partitioning scheme is 0 through 25. So and it's based on the first letter. So if I use Apple as the word, eventually. Okay, there we go. Okay, so when I used Apple, it communicated with partition, starts with 3B on node 2. But if I change this to Zebra, it's very hard. Then I'm talking to partition that starts with 2.9 on node 4. So that's kind of showing how to use that remoting to communicate with different partitions. So the next thing, showed that. Okay. Show some PowerShell real quick. So I mentioned before that Service Fabric has pretty robust suite of PowerShell commands to communicate with your cluster. One of the things you can do, I mentioned before, and this is in the SDK as well as PowerShell, but you can kind of send those health reports. If I go to my cluster, okay, so this is the cluster that I have hosted in Azure. So, okay, so send Service Fabric application health report. And then there's more than just application health reports. There's many different levels you can report on. So if I want to report on service or a partition, a specific partition, etc. Okay, so I'm going to give it the application name. I think that is getting started application. Health state, I'll give it an error. So any of your health reports have like the source and a property. So I'm just going to say the source in this case is PowerShell. Essentially, if you have like a service that is, reporting its own health, you might say the source is the service itself. Or you could have like a watchdog service. Its sole purpose is to report the health of a different entity. So it's just going to show up in Service Fabric. So if you're kind of creating these health reports, you might look for specific places that for the source of the health report. Health property, let's just say watchdog or something. And I can give it a description. Things are broken. Okay.
How does it know your credentials?
Okay, that's a good question. When you set up a cluster, there's two different ways to set it up. The first one is just have an open cluster with no security whatsoever. Probably not the best option. The other is through an X509 cert. That's kind of how I have this one set up. So when you connect to the cluster, you have to present it the certificate that it's using. And then that's kind of how it authenticate with it. And then actually you can set up Azure Active Directory access as well. So that's probably the easiest way. Let me show, I'll open up a incognito window and try and go to my cluster. So when I do that, I have to present which certificate it's using. So this one is using this thumbprint right here. So essentially, it's not going to let me into the cluster or connect to PowerShell to that cluster without the certificate. So, so now you can see the cluster has an error that I gave it. So when you do send a health report, that health kind of flows all the way up the cluster. So if If I'm reporting on the application, that puts the application type in an error. That puts the application, all the applications node, I guess, and then the cluster itself is considered unhealthy. If I were to put the health report on a partition, then again, it's the partition and the service and then the application are all considered unhealthy at that point. So let me go ahead and put that back to normal. So essentially, if I were to do an upgrade, a monitored upgrade where the service is checking for health between upgrade domains, if I were to send a health report that says it's an error, it's going to do a rollback. Okay. One last thing. Actually, two things. Am I good on time or? Okay. Okay. So. I mentioned before that one of the principles of microservices was to kind of be resilient. One of the things that Service Fabric kind of does in order to make sure that you do is, I'm sure, are you familiar with the term chaos testing or chaos monkey? There's actually a PowerShell command in here to essentially start chaos testing. So start Service Fabric chaos. Time, I can give it a time to run, let's say 15 minutes. I can give it the number of simultaneous faults to introduce at one time. So essentially, there's a number of different faults it's going to do. Restart code packages, essentially cause it to restart, like so maybe the code crashed, and then it'll restart. Move replicas. So for example, if I have a stateful service on this replica, a node 1, its secondary replicas are on additional nodes. It'll move a replica to a different node entirely. And I can't remember all the different things that it does, but essentially you can tell it the number of different faults to introduce simultaneously. So, because nothing ever just happens one thing going wrong. It's always like 20 different things. So you can kind of plan for that by running chaos testing when you're running or you're developing the applications. And for example, one of the things that might happen would be you could be trying to communicate with that naming service to talk to a different service. If it moves it, essentially you're going to get that error trying to communicate with it. Then it's going to re-resolve the address and give you the new one. So you want to make sure that your code handles that scenario because it's going to happen. Especially with Service Fabric, if you introduce nodes, it's going to move your services, willy-nilly. So number of faults 3. You can give it essentially a stabilization time, let's say 30 seconds. So when it's introducing these faults, if it determines that the services are unhealthy, essentially it's going to stop the chaos testing at that point. Then time between iterations, let's do 15 seconds. Wait time between faults, do 15 seconds. Okay, so, all right, so I just started the chaos testing. If we look at the cluster, we should start to see things just kind of go, wacky. You'll see things kind of go into a warning state sometimes, and in general, you can also see exactly what it's doing when it's running. So it hasn't actually done any faults yet. While that is happening, I might go ahead and do this as well. So this is when I deployed my cluster earlier, I actually used an ARM template. Essentially, it's Azure Resource Manager to create the entire cluster infrastructure within Azure. So right here, I have the number of instances I want in my VM or in my virtual machine scale set. Go ahead and bump that up to 10, and then just deploy to my thing, because this might take a little bit. Yes. So this is just a solution just to describe the infrastructure. I created the cluster essentially and told it what the name of the cluster was, how many nodes I wanted in it. I just used the default of 5. You can also kind of, if I were to look at this here, this is the different pieces in here. I give it the storage account, I create a virtual network, public IP address, load balancer, etc. So this is just setting up my cluster in general. So it has nothing to do with kind of programming against. I could also go into Azure portal itself and just say new cluster, but then I don't have like control over it. We typically like to deploy all these changes through the templates instead, because then like if someone just goes into the portal and starts changing things, you don't really know, like when things have, kind of why things might be broken. Or,
Yeah, here you've got a big version control.
Exactly, yeah. So let's see. Okay, so this is the chaos report. Now I see multiple faults that it introduced. One was to move a secondary replica. One was to restart a node. One was to restart a code package. So if we start watching this, you might see some things start to happen. And while that's happening, eventually I think we should start seeing more nodes get introduced as well. Okay, so did I do? Yeah, okay. Making sure I'm actually looking at the right cluster here. So. All right. Oh, okay. Apparently, I should have known that just kind of, changing the script willy-nilly was going to be problematic. So since I decided to upgrade the cluster and change the node count, essentially the chaos testing has stopped. It's saying since it's going through a cluster, it's not doing any more faults while it does that. Probably for a good reason, it doesn't want another variable, so for the upgrade.
Doesn't want to fail the upgrade.
Probably, yeah. So I guess that is pretty much all I wanted to cover with the demo until the nodes kind of upgrade here. We'll start seeing things just get moved. For example, we look at the actor service has, I think, 9 partitions, and then the stateful service has 6 partitions. You'll start to see things get redistributed in the cluster. While that is happening, though, is there any questions? Or all right, I guess we.
The life of the reliable dictionary, if all of your services have shut down.
It persists. So if your services stop, it's going to continue until you actually delete the service.
Okay.
The state is persisted. So and that's again, one of the reasons that it persists to multiple replicas is if you're let's say you have a virtual machine crash entirely, if that node goes down, if the primary replica is on node 0 and node 0 goes down, well, it's going to have at least 2 secondary replicas. It's just going to promote one of the secondary replicas to a primary replica. As soon as that node comes back up, though, it's essentially going to get any new state that might have been introduced while it was down, and it'll just be a secondary replica at that point. So, any other questions? Or, yep.
What kind of challenges and pain points do you think?
That's a good question. You know some of them, but I would say the biggest pain point for me has been It's kind of a steep learning curve. Like it's not like a lot of it's not straightforward as I would expect. Just kind of learning the ins and outs, and it's very broad topic too. You can't just understand just a few things and be successful with it. I think you have to know a lot of what's going on in order to fully, grasp. So the learning curve, and then I think the other is maybe visibility into the services, and that's probably not so much a service fabric issue as it is just a distributed systems problem. When you have hundreds of services communicating with each other, and something goes wrong in one of them, it's hard to know exactly like what happened, like which service. And we've kind of where I'm working now, we've kind of addressed those issues by creating like the logs that you see within the event tracing. You can view all those, but if you cannot like combine them to form a full picture, that's the problem. And unfortunately, I don't think there's like a really good out-of-the-box solution with Service Fabric. You kind of have to put that together yourself. So we kind of created like a correlation ID system where if you communicate with other services, make sure that they all share the same, kind of correlation ID, and every single log message you do, use that correlation ID. So like if it all starts from a web service call, you know what that correlation ID was, and then you can query every single log message based on that and see where exactly the exception occurred, or that's probably the biggest pain point in my opinion. So other than the learning curve. Yep.
When you're doing an upgrade, so you're showing you're pushing new binary, so you're doing a code upgrade.
Yep.
Do you have a time where old and new live concurrently? How does it know when to stop all the old versions and keep your?
Okay, so again, it's a rolling upgrade. So if it starts, it's going to start upgrade domain by upgrade domain. So if you have services, it's going to upgrade, domain 0. That might be just one machine in my instance, but if you have multiple, it's going to do all of the nodes in one upgrade domain and then move on to the next. Once the upgrade's fully complete, I guess I didn't really show that, but if I will go back to the application, right here. So I have all of the different versions still in the cluster, but you see that the only live version is version 1.0. So if I don't need those previous versions, I can actually unprovision them. But if I want to, I can actually upgrade to a previous version if I want to, and roll back essentially.
So if there's a long-running process in the middle of your upgrade, it doesn't kill it. It just adds on top of it.
No, it will kill it. So it might help if I show. For example, in this sample stateful service, I mentioned before the run async is kind of your entry point for the service. This essentially is just doing like an infinite loop, and every 30 seconds it's doing something. But it also has this cancellation token, throw if cancellation requested. If Service Fabric needs to stop the service, essentially it's going to cancel that. The cancellation token is going to request cancellation. So essentially if it's in the middle of something, it gives it, I think, by default, maybe like 30 seconds or a couple minutes to gracefully shut down. If it doesn't gracefully shut down, it's going to just completely kill it. So that's also something you kind of want to program for, is make sure that you gracefully handle shutdown. So let's see. Yeah.
I have a question. With that transaction that you were just showing?
Yes.
What happens if two nodes or two instances both try to run that transaction and update that?
There is
Will one of them throw an exception
well,
to retry after that? Or?
so I think by default, the max transaction time is 4 seconds, and then it'll throw. But depending on what you're doing, like if you're reading and something else is writing, it might be able to, it has lock escalation essentially. So it might, yeah, you might be able to, especially if there's, I mentioned before that there's the stateful dictionary, but there's also a stateful queue. So if you're, adding something to the queue and then reading something from the end of the queue, it might not have any issues doing that because one's going to the end, one's, pulling, so. Any other questions or? Okay, I'm not sure how long it's going to take to do the upgrade, honestly. So let's see. Virtual machine scale set. Yeah, unfortunately, I'm not sure how long this is going to take. It might take 10 minutes, but it's not going to be that exciting regardless because all of it's going to do is essentially start moving things to more balance it. So, yeah.
I have a cluster where I'm running 50 services.
Okay.
So the pain point I feel is maintaining the versions of those services.
Yeah.
So I have tried two different approaches. I have 50 different applications, each of them. running
Yeah. So.
service. The challenge there is then I have to go and deploy each of those 50 services.
Yep. So I think probably the recommended approach with that, and we started with that same approach too. And I think we're still kind of, for the most part, using that approach. But I think the recommended approach would be to group similar or related applications, because when you do, one of the things that I think the principles of the microservices would be they're independent, but obviously there are going to be services that depend on each other, and if you do have those dependencies between services, they should probably be grouped into one application and then do an upgrade all at once.
The problem in that case is then it's also difficult to maintain the versions. Either it upgrades everything, even if I change one service, it goes and upgrades everything. I'm trying to automate the versioning because every time it's a pain to go and read
Sure.
the video
Yeah.
and update the version. And if we have thousands of services to track the version of services,
Yeah, we maybe have, half a dozen, Marcus, is that 15 or so? So we haven't really dealt, I guess, on that same magnitude, but I feel your pain. That's probably,
and more problem is we have port version, we have config version.
yeah, exactly. So, I mean, obviously the easy case is, when you don't have code changes, you don't update the code versions. I think we also kind of on our, we tried to do the automated build incrementing, but like every time we, kind of create a new build, trigger that to update. But if you don't know exactly what's being touched, you don't want to just automatically increase the code version because then you kind of lose that advantage of, not restarting the code, when it, just a configuration change. So yeah, that's probably another pain point. I don't really have a great solution to that, unfortunately. So.
With a large number of apps like that, are you using dynamically assigned ports then, or are you statically assigning ports?
We have statically assigned.
And how many?
We have 50 services.
50?
We have 200 ports assigned, which we have been assigning as MND services.
So when you have naming service, where you're using static ports.
Because we don't know how to figure out which port will get assigned to which service.
Doesn't matter, right?
We are doing remoting between, so
So with the remoting, you definitely don't need to.
Yeah.
we need the ports to be exposed over HTTP.
So when you say remoting, are you talking about the?
The services interact within themselves as well as those that expose.
Yeah, I don't think you need to actually expose the ports in that case. But even if you did, I think it's the service partition.
So then you need a gateway, internal gateway that can route into other related services. That way you have one port.
But as of now, we have been using static ports. Because I don't know about naming service now.
Yeah, so the service partition resolver, essentially, that is the API to get to the naming service. You essentially tell it which service you need to communicate with, and then if it's partitioned, which partition, and then how you do that. Essentially, you just have to have your partitioning scheme known. For a stateless service, it's going to be most likely a singleton partition, so it would only have a single partition, but then it would give you a random node from that partition. So it could be on the same machine, it could be on a different machine, etc. But you should just have to give it the the name of the service and then the
So does that work across applications?
what's that?
Does that work across applications?
Across, yeah, it should. So you just when you give it the service name, you're giving it the full service name. So for example, if we look at this is the application and then this is the service. You have to give it this service name. So if I have another application in this cluster and then or even this service right here, if I need to communicate with the stateful service, which I'm actually doing in that other example, I think it's the web service communicating with the stateful service, but if you look at it, I'm not telling it which port in at all in my example. If I look at the code again, so in the controller, all I'm doing is saying service proxy create this interface, and I give it the full name of the service, fabric.net user group sample stateful service, and then the partition key, which I calculate based on the first letter, and then it will tell me where that service lives, essentially. So we do a similar thing in the applications we build. We use, instead of using remoting, we just use HTTP, like Web API, for everything. So again, you just have to tell it what the name of the service is. I think a lot of the services that are exposed externally, we will use a static port because the load balancer has to know what that is. But if it's internal communication, you don't have to ever specify the port. It'll just tell you what it is. So, and then what that kind of, I guess, helps with too, if I'm running locally and I have like a specific port that I'm using, then I can only ever have one instance of that service running locally because that port would essentially be, already in use. But if I use the dynamic port, essentially it can just choose a random one, and essentially I can have the same service, with multiple instances running. So when you do partitioning, essentially the partition is part of the full URL, so you don't have that conflict. But when you're doing just a stateless service, you do. So. Yeah, I'm not sure if this is going to complete in a timely manner. So, any other questions? Or? All right. Well, thank you for coming.
Thanks, Travis.
Yeah.
Appreciate it.